So for the next few days, we're going to look at solving different kinds of equations. Those were that we were doing were like polynomial equations. We're solving those. And now we're going to look at solving inequalities for a few days. And start with easy ones. Linear inequalities are pretty straightforward. There's a little bit of a trick. We get polynomial equalities, but we'll worry about that tomorrow. So one thing you want to know about a lot of this stuff is it's very similar to solving the equations like we've been doing. Like a lot of the techniques in the beginning are the same. There's a couple of little things you have to watch out for that are a little bit different, but for the most part, we're doing the similar kinds of skills that you are already good at, that you already have. The big difference is interpreting a solution. It's not the same as with solving just a regular equation. Okay, so we're going to look at 3 different ways that we can write a solution. So interpreting is one thing, but then writing it is another way. So with an interval, with set notation, or with a number line, or with a graph. You can do it with a graph as well, kind of thing. But and the textbook, different questions ask you to do it different ways, just to make sure you're familiar with all 3. Okay, so let's take a look at the first one here. Solve each of the following inequalities. So it's linear. There's nothing to it. 2x plus 7 is greater than or equal to 23. That's that kind of notation, hopefully, we're familiar with. So how would we solve this? Imagine the greater than or equal sign is just an equal sign. How would you solve it? Well, we'll move the 23 to the other side. So we'll move the 7 to the other side. Subtract 7, subtract 7. And I get 2x greater than or equal to 16. Divide both sides by 2. And x is greater than or equal to 8. So that's not necessarily finished. Before we write our final answer, let's think about what that means. It means that the expression 2x plus 7 will be greater than or equal to 23 for all values of 8 or higher, right? That's what that's saying. Does that make sense? It's a little bit different from like just solving. It says x equals 5. That's when the equation is balanced. In this case, there's all kinds of answers that will make that true. If I put 1 billion in for x, 2 times 1 billion plus 7 is greater than or equal to 23, right? So that will work. There's all kinds of values that will make this true when it's an inequality. Okay, so if I want to write this, let's say, as an interval, then I would say this is true, square bracket, 8, because it includes 8, because it's greater than or equal to 8, comma, and then when does this not become true? Well, never. So we would say to infinity, and infinity always has a round bracket. So you never get to infinity, right? So it always has a round bracket when you have infinity. So that would be interval notation. So if the textbook asks you to do it that way, that's how you'd write it. Make sense? Okay. Before we start the next one, something different is going to happen with the next one. This is one twist that we need to be aware of. It comes up very often with linear inequalities. And I said everything is basically the same. All the skills are the same. But there's this one twist. If I divide or multiply by a negative sign, that actually changes the logic in the question. Okay, so think about this for a minute. If I think of the 2 values 2 and 5, okay, so 2 is less than 5. Is that true? If I multiply that relationship by -1, what happens? I end up with -2 and -5. And what's true in that case? -2 is greater than -5. I'm going to write it the other way as well. So in this case, I flipped the numbers around and the sign stayed the same. But in this case, I left the numbers where they are. So I kind of multiplied by -1, and I had to flip the sign to preserve like the logic or the truth of that. It was true here. 2 is less than 5. If I multiply both sides by -1, -2 is not less than -5, it's greater than. So I have to flip the sign to preserve like the integrity or the truth of the statement. Does that make sense? So we always have to do that. Even if you're talking about an x or something, some unknown, you can see that when you multiply an inequality by -1, you're flipping the relationship. And that will be true for all numbers. So our rule is, we'll write it down. Okay, when multiplying or dividing by a negative, we reverse the inequality sign. So what does that look like in action? I'm going to add 5 to both sides. -3x is less than 15. And there's actually sort of 2 ways that you could think about this. Again, I think this will help like your conception of it, your understanding of it. There's 2 different ways that we could do this. The easy way, I think, would be at this point to divide both sides by -3, right? So we'll do that. I'll do that over here. So if I divide both sides by -3, I get x is greater than, because I'm dividing by a negative, greater than 15 over -3, x is greater than -5. So I reversed the sign. It was a less than sign, now it's a greater than sign. The other way you could think about this is, what if I just move the 3x to the right and move the 15 to the left? I'm not multiplying or dividing by a negative. I'm just adding and subtracting. That doesn't change a sign, an inequality sign. So I would get -15 is less than +3x. Well, that's the same thing, right? Divide both sides by 3, and I get -15 over 3 less than x, and -5 less than x, or x is greater than -5, right? Same thing. And I think most people would believe that that method on the right was fair. Everything we did there was fair. Some people might question, well, wait a minute, you can't just flip signs around, you can't just reverse signs. But what we did here was definitely right. All we did was move things across the inequality sign. I mean, just like if you move something across an equal sign, that doesn't do anything. Adding 5 to both sides, that's fine. Or subtracting 7 from both sides, that's fine. And in this case, we got x greater than -5. So we have to get the same answer in this case, right? You got to get the same answer. So we can, that's a different way of looking at it and realizing that, yeah, you got to reverse the inequality sign. That make sense? Pretty simple, I think. Like, you got to remember to do that, but otherwise solving these linear ones is pretty easy. What if it asks us to use a graph to solve? So this line is 2x plus 1, like y equals 2x plus 1. And then this line up here is y equals 5. When is 2x plus 1 less than or equal to 5? For what values of x? There's where they cross. So if I go bigger than x, if I go that direction, sorry, bigger than 2, if I make x bigger than 2, then this function, 2x plus 1, is bigger than 5. If I go this direction, if I go below 2, 2x plus 1 is below 5, so less than 5. The value of this function, the green function, is less than 5 at that point. So if you're solving with a graph, that's how you do it, right? You graph both relationships, look at where they cross, and think about, is it bigger than, is it less than, equal to, that sort of thing. So if I was going to solve this, it'd be 2x less than or equal to 4. Divide both sides by positive 2, x less than or equal to 2. And I can see that it's the same thing graphically. So let's solve, let's show this answer with a number line. Okay, so I'm going to have positive 2 here, and 1, and 0, and so on. And this is like when we did the absolute value stuff, same idea. So at 2, and it includes 2, so it's a closed circle because it's less than or equal to. So when x is less than or equal to, that's how you show that answer with a number line. Simple, straightforward. Okay, last one. No questions, are you sure? What happens if I have a double inequality? Now, first of all, there's a chance that sometimes double inequalities aren't possible. There's a chance for all inequalities sort of to be not possible, but it would be strange for a linear one not to be. But for a double inequality, certainly if it's set up the wrong way, it might not be solvable. There might be no values for which it's all true. But I hope this one works. So there's two ways you can do it. Sometimes, some teachers will break it up into 2 separate questions and solve them separately, but you can actually solve them all together as well. So I'm going to add 3, but I have to add 3 everywhere. So 12 greater than or equal to negative x greater than or equal to negative 1. Can you think, yes? Oh, greater than, or sorry, this one's just, yes, thank you. Is that what you're going to say? Yeah. I was making. Thank you. Can you think of any values for x for which that's true? Could you pick a value and try it? Would 1,000,000 work? Would 9 work? Would negative 18 work? I'm missing a what? Negative 1. Missing a negative 1, is that what you're saying? That's a rhetorical question. You don't have to answer it, but can you think of values for x for which that's true? Okay, so now we have to divide by negative 1 or multiply by negative 1. So now I get negative 12 less than or equal to x less than 1. If I was going to answer this with interval notation, it includes 12, but does not include 1. If I was going to do a number line, right, it's going to be an open circle on 1 because it doesn't include 1, but it does include negative 12, so closed circle on negative 12. Any questions? Okay, there's a few to practice.